Well, welcome back to ArmanisMath. Today we're going to focus on linear equations and inequalities. Start with the warm-up. Give you about 4 minutes for this one. Please do the warm-up. I'm going to have you share your answers on the whiteboards. So about 5 minutes for this one here. Some of you will be done by then. Yep, see that cool? Right. I see that, Elijah. Okay, so let's get started with this one. Who's got, thank you. I need somebody to mic up and help me with number 2. See that face? And do you do anything else? That's correct. So 6x. Good catch. Janine, I see that. Yep. Okay, and number 4. Somebody help me with number 4. Get an echo here. Okay, so this is 3 here. And then this is 4 and 4. That's 3 times that, which will give you 3x plus 6 over 12, 4x over 12. And then what we do from here. That's true. That's 7x plus 6. All right, can I simplify the 6 and the 12? Be very careful, okay? Since it's connected to another term by the addition or subtraction, I can't. So I have to be very careful. The best answer is what I see here in front of my eyes. That's the best. There's no way to, if this is multiplied, yep, I would say go right ahead. But that's not the case, so we're going to be careful of that one. All right, who else? That's it. I think we're ready for, I'm going to give you some answers. So you just, when you're watching this afterwards, you would have some answers for it. So you should be taking notes, obviously, and here's a good example of things that you could put on the notes. Warm-up is important, so it helps us focus on the lesson. Let's move on, and this one is going to be the objective for the day. I will be able to solve linear equations and inequalities in one variable. So a couple of kind of theory behind the scene things that you see it every single time, but you don't realize that you're knowing it. Some properties. The first one is called reflexive property. Thank you, Cole. The first one is called reflexive property, where you say 5 equals 5. That's called reflexive. X equals X. Symmetric. Symmetric would be U equals V, then V equals U. Like X equals Y. Okay, that means Y equals X. Transitive. U equals V, and V equals W. Hence, U will also be equal to W. It's like my friend's friend is my friend. Something like that. Addition. U equals V. W equals Z. If you added U to W, that means you're also adding V to Z because they're equal. Multiplication. U equals V and W equals Z. Then U times W equals V times Z. I know there's a lot of things here that you kind of, I shouldn't say don't really care about, but again, you are doing this without you knowing that this is actually a property. So relax. I don't want just the naming here or the labeling to bewilder you, because it shouldn't be. It's just you actually doing this every day in math life. So linear equation in X, and that is one variable that can, it says here, is one that can be written as in the format of ax plus b equals 0. And obviously a cannot be equal to 0, because if a is 0, that means the x is 0, and you only lift up with a number. So that's an equation of x in one variable. Okay, then it's not x and y here, just one variable here. Basically, they're saying you have to have at least one x and then the equal sign and then a 0 or a number. Okay, more on these as we have done in the warm-up. Some operations that we use for equivalent equations. For example, you could combine like terms. The 2x and 1x becomes 3x. So you also could do subtractions here. Second thing, you could perform the same operation on both sides, which we know this by now. If you want to add 3, if you want to subtract 3 from both sides, you do it to both sides. If you want to subtract, you subtract from both sides. If you want to multiply, well, same thing, multiply both sides. If you want to divide, you divide on both sides. So basic operations here that tells us kind of a framework of what we're doing with equations and inequalities. Just as I said, you've been doing this all along. So the first one here, okay, so put example number 1, and this example would be very simple and to the point. This example would go like this one. Prove, example 1, prove that x equals -2 is the solution of x squared. I'm going to start with something that is not plus 6 equals 0. So if I'm asked to prove that this is a solution and I'm given a proposed solution, this is a proposal, but we're saying x equals 2. Then all what you have to do is actually plug that in. Substitute x equals -2 in every single time you see x. So in this example, I'm going to have -2 squared minus -2 plus 6 equals sign. And then you have to have a question mark. And that's a biggie here, because remember, you're trying to prove. You're not sure. Maybe it is, maybe it's not. So that's what we're trying to prove. Equals 0. What is -2 squared? I need more chats, more whiteboards. We need to hurry up. We need to pick up the pace, you guys. Got a lot to cover today. So we got 4 minus -2. That's plus 2. That's 4, and this is minus -2. That's plus 2. Plus 6 equals 0. And then you're asking yourself that question. Does that really equal to 0? The answer is no. That doesn't equal to 0. So what's your conclusion on this one? I did propose a solution, but that was not a solution. So that's what you have to say. X equals -2 is not a solution. Okay, now I want you to try this one here. So I want to take this concept. We're still doing x equals -2. However, I'm going to tweak the function just a little bit. Okay, just a different function. So for example, what have I said? My function now, my function or equation is x cubed minus x plus 6 equals 0. Does or is x equals -2 a solution? of this equation here. Is there a solution of this? Try it and show me on your whiteboards. If you're watching the video afterwards, make sure that you pause, obviously. Don't just wait for the answer. Make sure that you do the work. Okay, is this a solution? Kevin, okay, interesting. Satar. Jordan, I like that. That's very good. Satar, I would look at the sign. So remember, this is cubed. I'm not sure, Kumar, what does that mean? Oh, okay. Actually, no. Look at the sign. You probably have missed the sign. So let me see what you guys got here. Alan, you're good. LZ, if you could just take it up just so I can see it. Alexa, you're good. And I don't see the work, Angeli. I'm assuming that you have it somewhere, but the answer is correct. Antonio looks good. Faith is fine. Check that, Kevin. George, check that. Check the negative sign. Kumar, check the negative sign. Natasha, check the negative sign. And Priscilla, if you could put the word up a little bit. That looks good, Natasha. I'm sorry, Priscilla. Priscilla is good. Janine, that looks good. Liana, I would look at it again, okay? Look at the negative sign. Okay? Jocelyn, that looks good. So, I would look again. Cool. And Alice, are you good? Okay, guys. So let's do it. So I've got -2 cubed minus -2 plus the 6. Does that equal to 0? And this is -8. A lot of us made a mistake here, so maybe I need to change the color. This guy's -8. Okay, and that's negative times, that's plus 2 plus 6 equals 0. I've got a -6 plus 6, and that equals to 0, since 0 is equal to 0. So here you say x equals -2 is a solution. Okay, I bet you a lot of you have, that's what I've seen from your whiteboards, you have not cubed the negative sign. So it's negative times negative, that's positive, times another negative, that's going to make it a negative. Okay. What else we need to see here? Let's do another simple one, okay? We're going to do one that is similar to example 2 here. Similar to the one on the objective, and this one is going to be let's do something like this. Let's say, for example, 3 minus 2x plus 2 plus 2x plus 3 equals 5x minus 4. Okay, we need to solve this equation, and remember this is one variable only, one variable. So somebody, if you would like to try this with me, you could mic up and start talking to us. I'm gonna distribute. Again, distribute. And again, distribute. I'm not gonna neglect there's an equal sign here. Be careful, there's an equal sign here. So 3 times -2 is how much? Give me the first term. This guy here. Go ahead and multiply 3 times this and give me. I'm looking at the chat. -6x plus what? That's right. Plus, come on, you guys. 2x plus the 6. Don't wait for me. And then how much would it be here? A lot of you are writing on the chat here. Good job. X minus 40. 40? That's 20. 5 times 4 is 20. All right. And obviously, what do you think I'm going to do here? We talked about this like last slide, a couple slides ago. You do something here. That's it. Combine like terms. So I'm going to combine this with this dude on this side of the equal sign. So I've got negative. That's going to give me a negative. And obviously these two also. If you have one color, you could make that one color 2 distinct, or 4, or whatever, how many times you want distinction, by maybe one straight line, one squiggly line of the same color. So I've got -6x, and that's a -4x. 6 and 6 is 12, equals 5x minus 20. Okay, I'm gonna tell you one thing right now, which you're gonna probably find it helpful. There is nothing wrong with me subtracting the 5x from both sides. There's nothing wrong with that. I just wanted you to condition your brain to end up with positive x's as much as possible. And there's a reason for that, obviously, when it comes to inequality. So try to end up with positive x's. So yes, I could subtract 5x from both sides, making this -9x. It's probably easier, again, to subtract the little guy from the big one, just to end up with positive x's. So this is what I'm going to do now. I'm going to add 4x to both sides. Is there anything wrong with me subtracting 5x? No, there isn't. I'm just recommending that you stick with positive x's. 9x's minus 20. What do you think I'm going to do now? What do you think I'm going to do now? Hello? I'm going to add the 20. Thank you. 20 plus 12 is how much? 32 equals 9x. I'm interested only in 1x, not 9 of them. So I have to divide both sides by that amount, which is going to give me a weird number. There's nothing wrong with that. 32 over 9. And I'm just going to leave it the way it is. Now I'm going to do this one time, okay? I'm going to do this one time because I need to check the answer. Usually you would check the answer. In math, you solve the problem, you come up with the solution, but guess what? You've got to check the solution to see if it's going to work. It's a solution of money. Well, you'll be amazed. We're going to find some solutions in this class that do not work. And you work too hard for the solution, and then it finally will be called that an extraneous solution. A solution that doesn't work. So that's why we say we have to check our answers. So if I were to check my answer, I would highly recommend that you would go and check it in the original equation. So put 32 over 9 in every single time you see x, which is going to be kind of cumbersome here and here. But that's the optimum is if you want to make sure that this is the correct one, you take 32 over 9 and then plug it here. And then you multiply, plug it here, and then you distribute, plug it here, distribute. Or if you carefully have done your work and you know that this is really carefully done, then you probably choose something simple like, perhaps something simple like this to check, you plug it in. Or perhaps something simple like this part here, 12 equals 9x minus, or even down here. So that would be 32 equals 9x. So I'm giving you alternatives here, but you just have to check your work. So for example, if I take this dude here, I'm going to highlight that for you. This piece here, this piece. If I said 32 equals 9x, so let me check. This is the check part. Oh, why is it not writing? 1 second. Okay, let's check here. Interesting. What if I went this way? Yo. Okay. I'm not sure what's going on. Software is not responding. Okay, keep in mind, so I've got 32 equals 9x. Let's see if I could bring that up. That's not even, oh good, okay. So we'll just have to go back here. Here we go. 32 equals 9x, and I'm going to try this, see if it's going to work. Basically, I'm going to plug, so I've got 32 equals 9x. Question mark here. I'm trying to see. 32 equals 9. What's my x? Well, it is 9. It is 32 over 9. So this is 9 times 32 over 9. Well, let me see. I could make this 9 a fraction. And that becomes 9 here and 9 here. I'm multiplying, so I'm easily simplifying. Chop chop, my fruit ninja. That's going to give me 32 equals 32. Which means my choice was correct. That means whatever I choose here for x is the solution. This is the check step. Now, I kind of did the shortcut, but usually when you do this, you will need to take this x equals 32 over 9 and actually plug it in all the way at the beginning of the problem, just in case if you made a mistake in these steps. So you just want to protect yourself, you just put it at the top here. I know it's cumbersome, but it's worth it. Obviously, we're not going to do this every single time. I'm expecting you to do it, but we're not going to do it in class every single time, every single problem. But part of finding a solution in math is actually you checking the solution to see if it's going to work. Armani is a solution. Again, I'm saying we will find solutions in this class that do not work. We call them extraneous, or sometimes we call them erroneous solutions. Okay? All right. Let's see what's next for us. Next for us would be something interesting like this. So, gear up now for some work. Because this one has a fraction, we are blessed that we have a common denominator. So, for example, if you looked at this problem, I see 10y minus 4 divided by 4 equals y over 4 plus 2. And by the way, I could also make this 2 a 2 over 1, right? You could make this a fraction. It's a real number, so you can make it a fraction. So basically, I am spotting a common denominator. I'm spotting the 4 and the 4 and the 1. And I want to find a container big enough to contain the 4s and the 1 with no leftover. What do you think I'm going to do? A common denominator between the 4 and the 1. What would that number be? Multiply what by 4? I just need a big number container to contain the 4 and the other 4 and the 1. What could that number be? So the thought is this. So this is the least common denominator. That's kind of the concept here. So I wanted a container that contains the 4s and the 1. So I'm gonna pick, okay, I like that. Think with me here. I'm gonna pick the 4. The 4 is big enough. The 4 is big enough to contain itself, right? So I have a blob, whatever you want to call it here, a blob of 4 here, okay? That thing is perfect fit for that 4. So that's 4. How about the 1? Sure, you could put 4 1s here. Here's 1. Here's 2. Here's 3. Here's 4. 1, 1, 1, 1. You could put 4 1s with no leftover. That's why the 4 is perfectly fine. It's a least common denominator, and it's perfectly fine for both of these numbers, the 4s and also the 1. Right? So if you have ever thought of seeing least common denominator in this concept, tell me yes in the chat. If you have not seen this before, tell me no, I have not seen this before. The concept of a container for the least common denominator. Remember, you're trying to find one that actually has capacity to hold them perfectly, line them up perfectly with no leftover. I don't want to see any halves dangling here or 1/3 spilling out here. I don't want that. I just wanted perfect numbers. So what do you think is a least common denominator between the 3 and the 4 and the 2? Which one do you think I'm going to pick? Come on. Come on. More chat answers. More. It has to be 12. Why does it have to be 12? Well, think. If you have a 12 container, 12, that's going to fit how many 3s? Well, let's start with the big one. It's going to fit 3 4s. Here's a 4. Here's another 4. Here's a third 4. 4, 4, 4. How about 3s? Well, we've got 4 of them. Sure. I got here's a 3. And 2. And 3. And 4 3s. Okay, excuse my... 3, 3, 3, perfectly. Nothing is spilling out, nothing is dangling here. That's a perfect 3. Okay, what about the 2s? Well, also the 2 could go perfectly inside here because you have 6 2s. So you have a 2 and 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 a 2. And all these will also line up perfectly. That's why the least common denominator is for these guys is 12. Anyways, that was just a side note. I'm glad that we spent time on this. It's going to help us in the future. So that's what we do for least common denominator. Why am I doing this one? There's actually an easier tool, but it's okay. So now I have to have 4. Once I got that squared away, now I really have to think about how do I deal with this common denominator. So now it's going to be divided by 1. And what it turns out to be is every single one is going to be affected by this 4 that you picked. Every single one, no exception. So you put 4 on this side of the equal, 4 on this side of the equal sign, and everybody's going to be affected by that. 4 is going to be times this fraction. 4 is going to be multiplied by this fraction. And by this fraction. So basically what you're saying is 4, you also could make it 4 over 1. Give yourself enough room. Divided by 4 equals, again, 4 over 1 times y over 4. Again, plus 4 over 1 times 2 over 1. Okay. So let's do the math. I need who's got the fruit ninja here? Who's got the fruit ninja? What would I do? What do you think I'm gonna do with the 4? The whole thing. Exactly, to get rid of the fraction. That's the reason I'm finding a least common denominator, to get rid of the fraction. So basically, I could look at this. This 4 is going to go bye-bye with this 4. This 4 is going to go bye-bye with this 4. This 4 can't go bye-bye with this 1. It's just 4 over 1. Just a 4. So if I were to rewrite this, clean up a little bit, so this nothing is just a 1. I've got 10y minus 4 equals 1 times y is y, plus I've got 2 times 4, which is 8. Okay. And let's do this. I want, obviously you could subtract negative 10y from both sides. I'm not saying it's wrong. What I'm saying, you're just complicating things. So make it simple. Subtract the y and keep things positive. Keep positive thoughts, okay? I know things could be tough and rough sometimes, but we're going to focus on the positive side. So I got 9y's minus 4 equals 8. Add 4. Add 4. I've got myself 9y's on this side equals 12. Okay, are you with me? I'm going to subtract both sides by 9. And y is going to be what? What would y give me here? 3 over, that's a 3, no, that's not 3. That's a 4 over 3. 4 over 3. That's it. That's my answer. That's what I believe is the answer, right? It might not work, but at the beginning of class, obviously we're going to have some working solutions, but sometimes it don't work. So 4 over 3, so you're going to take the 4/3 and you're actually going to have to put it back into the original equation and then check if it works. Perhaps the biggest or the closest one is 9y equals 12, and you're just going to put it there and it's going to work. But my advice again is to go all the way up to here and plug in here. For every y, you're going to plug in 4 over 3. I know, trust me. It's going to be a fraction divided by fraction, so you're going to have a fraction at the top and then fraction at the bottom. But if you want a shortcut and you're really confident of your work, you also could do it in any of these equations. I'll probably do it here, or here, or here. All right, that is this one here. I have a feeling that we need to practice this concept. If you agree, give me true. Hold on a second. Un momento, por favor. Give me a true if you feel that we need to practice this a little bit more. I mean, like one more example, Armani would just do. Okay. All right. Looks like we're doing good here. That means we need to do more of this, which is perfectly fine. Come on. So I'm going to go here and let's do another example. Why don't we try this one? I've got, so that'll be example 4 for you, right? Example 4. Let's try 5y minus 2 over 8 equals 2 plus y over 4. Okay. What do you think is going to be my least common denominator? Hello? What do you think is going to be my least common denominator here? Remember, you really have to pick one that is big enough for the 8 and for the 4. And I like, okay, Laura, I'm okay with that, but is that way too big? This is going to work. I mean, anything big is going to work, obviously. But is that way too big? And if you pick 12, then you're going to have to question the 8. Would I be able to fit 8 or multiples of 8 in one container with nothing spilling out of that thing? Or am I going to have problems? So I'll stick with the 8. Yeah, 8 is a good choice because 8 again is a big enough container for all these. So what do I do? Well, because you are doing an equation, 8 will have to multiply by everyone. 8 or 8 over 1, obviously, or 1/8. So that's going to be multiplied every single. There's no other option. You just have to do it. Just do it. So now 8 over 1 times the 5y. Get your fruit ninja ready. Equals the 8 over 1. Use parentheses. They will help you. Plus the 8 over 1 divided by y over 4. All right. Let's do the chop. The 8s are going to be chopped. Nothing here. The 8 and 4 will be also simplified. So 8 is 2. This is gone. The 4 is gone. Bye-bye. 8 and 1, well, that doesn't make any sense. You just leave it because you're not simplifying it. So now I've got 5y. I got rid of my, look at that. I got rid of all my fractions here. There's no need for fractions. It's all 1s divided by 1s divided by 1s. See that? Minus 2 equals, that's a 16 plus 2y's. I make myself comfortable by subtracting 2y. Can I subtract 5y's from both sides? Can I subtract 5y's from both sides? Yellow. Can I or can I not? Would I be able to? I could, but you're going to have to keep track of the negative because you're going to end up with negative y's. Why would you do that? I have no idea. Well, some of us like that. So 3y minus 2 equals 16. Add 2. 3y's equals 18 divided by 3 y equals the 6. Okay, come on. That's not going to be an exception here. You take this dude here and then this is what I used to do for my kids, my students. This is, yeah, you're happy and jolly, but this is 90% done. What are you, oh, come on, Armani. Oh, this worked for 90%? Yes, because you got to take it and plug it and check. Shake it out. Gotta check it out. You gotta plug it in. So I got y equals 6, and obviously there's no excuse here. You really have to go at the top here. So 5 times 6 is 30 minus 2. How much is 30 minus 2? How much is 30 minus 2? 28 divided by 8. That's what I get from the left side. So I'm gonna do it here. Obviously, as I said, I'm not going to keep doing this, but just for your sake, guys, because you guys are awesome. This is my check part of the things. Check. So I've got 28 over 8. Does that equal 2? That's my question. We're trying to test it. I've got a 2, or 2 over 1. And I've got y over 4, or 6 over 4. So I've got, basically, I've got 2 over 1 plus 6 over 4. What is that? What's 2 over 1, 6 over 4? Can somebody find out? I've got 2 over 1 plus 6 over 4. Well, you've got to make this guy also a 4. So you multiply this by 4, which is going to make it a 4. Multiply this by 4, which is going to make it 8. Okay? So 8. And then you're going to say 28. Can you simplify 28 over 8? What would that give you guys? What's 28 over 8? Is 14 over 4. 28 is going to be a 14 over 4 equals 14 over 4. Yep, this solution works. Okay, Okay, so there should be no excuses for this thing here. Inequality. Well, linear inequality in X, almost same description as the equation, is one that can be written in the form of ax plus b less than, obviously less than equal to, greater than equal to, the 0. And the a and b are real numbers, and a is not 0. Sure, because if it's 0, that means there's nothing here. You're going to end up with b less than a number. That's not linear inequality when you have x. Same rules that we talked, transitive, addition, multiplication, exactly what we've gone through for the equation. The same thing for inequality. Okay, 1 second. So let me add some things that we need to play with. So let's play with this simple one here. I've got myself, example 5, exactly 6. I've got myself something that looks like this: 3 x minus 1 plus 2 is less than or equal to 5x plus 6. Okay, well, let's get started. Who's going to help me out here? 3, what would I do here? Hello? What's that word called? What would you call that? Yep, 3x minus. Check it again. Cool. 3x minus. Yep, here we go. 3x minus that amount. So 3x minus 3 plus 2 is less than equal to 5x plus 6. Combining like terms. So I'm gonna do it the easy way first. I'm gonna stick with my recommendation and subtract the little guy from the big guy. So I would not end up with negative. And I'm also gonna do it the other way. Okay. So this is going. Is this? Oh, what about negative 3 plus? That's the negative 1, right? So I'm gonna end up with negative 1 on this side, less than or equal to. I've got 2 x's plus 6. Subtract. Oops. I'm thinking about the solution before. Subtract. And that's going to give me negative 7 is less than or equal to 2x. Well, I'm really interested in 1x, not 2 x's. Sure. Divide by 2. The x and x is here, and this is greater than negative 7 over 2. Just leave it the way it is. Negative 7 over 2. By the way, we are in math. You're accustomed to do what? We're starting with a variable. So basically, you just have to say, you read it from the variable. Start reading from the variable. So this is x, and look at the jaw. Jaw is towards x. X is greater than negative 7 over 2. Okay. Now, hold on a second. Is there a different way to do this? Yes, there is. Yes, there is. So let's take a look. I'm going to come here and say, you know what, Armani? I really like what you said, but at the same time, I want to just venture out. I want to try things. For example, I want to come here, and instead of me subtracting the little guy from the bigger one, I'm actually gonna just subtract the big guy from the little guy. Okay, well, that's fine. It just means you're gonna end up with a negative. So in this case, you said, okay, you know what? I'm not going to subtract the 3 x's. I'm going to add, subtract the 5 x's from both sides. Sure. So that's 3x minus 5x minus 1 less than or equal to 5x plus 6. And you just said that's what you chose. You chose to do plus 6 here. You chose to subtract the 5 x's. Sure. So now I got negative 2x is less than, there's a negative 1 here, minus 1 is less than or equal to, and I've got myself a number that looks like 6. It is a 6. Okay, I add the 1 to both sides, so I have myself negative 2x is less than or equal to 7. Now be aware. Here's your choice. I mean, we all make choices. So now we have to be aware of what we just did. I just want you to watch this here. Like, watch this guy. Since now you have your coefficient, the number next to, the coefficient is the number next to the variable, which is x. You've got negative 2 here. You remember, you wanted just x. So you're going to have to divide by negative 2. So this is what happens if you divide by negative 2. The inequality flips. It doesn't like it. This inequality flips. So that has to become now greater than or equal to the negative 7 over 2, and that's your x. So what I'm trying to tell you, you could do the negative x's. It's perfectly fine. You just have to be aware that you have one more step to take care of in case if you end up with negative coefficient. Whatever you're going to divide by, if it's negative, remember it has to be the coefficient, not the number here. It has to be the number next to the x that you're defining by. So if that is negative, then you just have to remember to flip. Well, how many of us do forget to flip? About 85% of students forget to flip. So anyways, I'd probably stick with this, but both are available for you to choose from. Okay. I want to show you this last one, which is going to amaze you. Okay, this is example number 7. This one has 3 parts. What? Yeah, 3 parts. An equality that's got 3 portions to it. 3? Yes. So let's try. I've got negative 3 less than or equal to, just less than 2x plus the 5 divided by the 3, and this is less than or equal to the 5. So first thing first, I need to get rid of the fraction. My fraction is icky. I don't like the 3. Well, you know by now that you could get rid of that by multiplying every single one by 3. And I really mean every single one. Not just the 2 sides of the equation, but now we got 3 of them. Sure, got 3, and then you have to multiply the 3 times this, and the 3 times that. So this is going to be 3 times negative 3, less than 3 times the blob, 2x plus 5, over 3, less than or equal to 3 times the 5. All 3 sides are money. Yes, all 3 sides. So that's a negative 9 is less than, chop chop, ninja, fruit ninja, chop chop. I will have myself a 2x plus 5 less than or equal to 15. Well, okay, I just wanted 1x. Okay, what can you get rid of? The 5. Only 2 sides are money? No, 3 sides. Negative 5. Negative 5. So I've got myself negative 14 less than 2x's less than or equal to, I got myself a 10. Okay, I just needed 1 extra money. Sure. Divide by 2. How many sides? Tell me in the chat. How many sides? Hello? Yes! Yes! All of them. All 3 sides. So I've got negative 7 less than x less than or equal to 5. And we know by now how to graph this. Of course you do. You've got yourself a 0. You've got yourself a negative 7. And you've got a 5 here. Do you think I could bubble the negative 7? Bubble the negative 7 or not bubble? Should I fill in the negative 7? No, Armani, because it doesn't have an equal sign. You only fill the 5. Okay, champions. So don't forget, for inequalities that got 3 parts, you gotta take care of everybody in that household. Okay. Any questions on this?